Hi everyone, my name's Stephen Turner from Intergence. I'm the VP of Optimization, and with me is Alan Cottom from Stonesoft, and he's one of their solution architects. And today we're going to be talking to you about how you can identify, prevent, and secure your networks against the unidentifiable attacks which can go on there. So we've got some really interesting things to talk about today. Just a bit of housekeeping really. Thanks for joining. Please note that during this webinar we're using audio broadcast, and so if you can see the small box in the right hand corner of the screen, that will need to remain open throughout. If you need to chat to me, or if you want to submit a question, click on speech bubble in the top right hand corner and then type in the text box. If you want to submit a question for discussion at the end of this demonstration, then please click on the question mark in the top right hand corner and open the Q&A box. If you're having any sort of technical difficulties during the webinar today, then you can either email Intergence at news@intergence.com, or you can speak to us directly through the chat bar. So please let us know if there's any issues. So the agenda for today has three parts. The first section is from Alan Cottom, who's from Stonesoft, and he'll be talking to you about how advanced evasion techniques can infiltrate your network, what they are, and are you actually protected against these. Following on from him, I'll be giving you a live demonstration of our 3D visualization tool called Hyperglance, which enables you to actually get a full view of what's going on within the network and takes a sort of holistic view of the entire IT infrastructure. Then after this we'll have a Q&A section where I'll answer, and Alan also will answer any questions which may have cropped up during the webinar. So now I'm going to hand over to Alan to talk you through the advanced evasion techniques.
That's brilliant. Thanks, Steve. Good morning, everybody, and thanks once again for attending this webinar. This morning, I'm going to talk to you about a relatively new discovery in the world of attack methodologies when we're talking about compromising people's network security solutions. And this new methodology is based around advanced evasion techniques. First off, though, just a little bit about who Stonesoft are. Stonesoft are a Finnish organisation who have been around for 22 years now in the security arena. We concentrate on both physical and virtual security, and as a result of this, it's the research and the development into our existing product solutions that has opened up the window on these extended or these advanced evasions that can be used to bypass network security solutions. So I'm sure everybody's familiar with using technologies such as intrusion prevention systems, intrusion detection systems, and even next-generation firewalls that have that next-generation functionality of being able to do deep packet inspection or even forms of IDS or IPS within there. And it's these technologies that are under threat from the advanced evasion techniques that we're going to talk about today. So if we start off, first of all, with a definition of what an evasion is. Whilst you're reading through that slide there, I'll give you some background into this as well. And it all really stems back to the original days of TCP/IP, when people wanted to be able to send messages and send emails, for example, between disparate systems using a common technology. And over the years, particularly back in the early days when TCP/IP was developed, one of the last things in its scope for development was security. And over the years, as more vendors and systems integrators have tried to conform to particular standards for communicating between disparate hosts, a standard developed, which was the standard for TCP, which was RFC 791. Now, the general idea of that RFC was or the founding stone of that was a general principle of robustness. And what that principle of robustness says is that if I'm a sending device, then I have to be conservative in the way I send my data. So therefore, I have to conservatively encode and transmit my packets across the network. But at the same time, if I'm a receiving device, then I have to be liberal in how I receive that data. And what that means is I have to be able to interpret packets as they come to me, reassemble them within my TCP/IP stack, and then deliver them up to the application that I want to send to. Now, just because vendors, security vendors, operating system vendors, and so on, all agreed on this particular standard for TCP/IP and the methods within there for encoding and transmitting those packets, that doesn't actually mean that that is the only way to do that. There are actually a multitude of ways to encode and transmit packets across a network, and it's that multitude of ways that actually allows us to take advantage of that and use evasion techniques to bypass existing network security solutions. So if we start with a quick timeline or a potted history of evasions and advanced evasion techniques. First off, evasion started to become more apparent back in the sort of mid to late 90s. You would first see the papers appearing within research papers that would discuss ways on how you could bypass network intrusion detection or even launch attacks against that type of security solution. Later on in 2004, suggestions were made that it was actually possible to combine evasions together. Now, what we mean by that is typically evasions were only delivered in a singular fashion, in that they could only be used on their own. They were pretty much targeted to either a particular exploit or a particular application, but they couldn't be combined together. But the possibility to combine came about in 2004. Jump on a little bit to 2007, and that's when the Stonesoft R&D team were given the task of actually looking more into evasion research, with the ultimate goal of improving the overall security of the Stonegate intrusion prevention system. And back in 2007, there were relatively a small number of known evasions, or what we now term the traditional evasion methods. And by traditional, again, I mean they were designed either to work against a particular application or for a particular exploit, and they couldn't be combined together or stacked together, which made them relatively easy to detect and therefore block within intrusion prevention and intrusion detection systems. Skip on a few years more to 2010, after a great deal of research by Stonesoft, we then shared our new findings on a new evasion threat that we discovered during our research phase. And through the coordination of the Computer Emergency Response team, we delivered 23 stackable advanced evasion techniques. Now, the key point there, and again, because that doesn't seem like a hugely large number, the key point there, the key word in there, is the fact that they were stackable. And what we found was we were able to combine multiple evasions together to create new evasions. So even though there were only 23 AETs delivered through CERT, the actual number was 2 to the power 23 of possible combinations of different attack methodologies to help deliver exploits through existing network security solutions. CERT at the time independently verified and tested our findings, and then they sent out coordination efforts and reports to all of the other security vendors to say, okay, come on, we need to address this problem, and you need to make sure that your solutions are able to detect and stop attacks delivered within advanced evasion techniques. Throughout 2011, the Stonesoft vulnerability team continued their work and research into advanced evasion techniques, and on the back of that, last February, we released a further 124 new advanced evasion techniques, and again in October, a further 160. So where that leaves us today is with an approximate 2 to the power 300 possible advanced evasion techniques combinations. That means 2 to the power 300 different ways that we can encode and transmit packets across a network that don't necessarily conform to the standards that today's security solutions are actually inspecting and looking for. So what are advanced evasion techniques? Well, put simply, they are any method or technique that are used to implement a network-based attack in order to evade or bypass existing security appliances. Again, whether they're next-generation firewalls, whether they're intrusion prevention systems, or even whether they're intrusion detection systems. And the things that make them advanced are the fact that we can now combine multiple evasions together and deliver them simultaneously across multiple levels of the protocol stack. And not only that, that combination of evasions can actually change during the attack as well, which makes it even more difficult for the target security system to actually interpret what's happening and therefore successfully identify the malicious attack that's taking place. And something that I want to clear up at this point is the difference between AETs and APTs. I'm sure you're all aware and have all heard the threat of advanced persistent threats, which is the APT. That is not the same as an AET. What an APT is the actual motivation. It's the fact that an individual or a group or a nation state, for example, have decided that they want to compromise your network and obtain information or cause a denial of service, but they want to target you or your organization. An AET is the method in which they're going to achieve that, or one of the methods in which they're going to achieve that. So an AET is a way of compromising your network security by delivering an exploit through the network. Another method of an APT might be social engineering. So AETs and APTs are fundamentally different, but they can actually be used together in order to gain entry into an organization's network. So at this point, you may be asking yourself the question, well, okay, I've done my due diligence, I've gone out and I've perhaps looked at the Gartner Magic Quadrant and I've identified who are the key players in terms of next generation firewalls, intrusion prevention systems, intrusion detection systems and so on, and I've purchased one and placed it on the network. And, you know, that's actually the absolute right thing to do. What we have done, though, during our testing is that we have gone out to the Gartner Magic Quadrant. We've identified all of the highest ranked security devices in there, and we've purchased them and placed them within our security testing labs. And we've run the advanced evasion technique tests against not only our own solutions, but also all of our competitor solutions. And we've found that it is possible to effortlessly evade all of those leading security vendors when it comes to advanced evasion techniques. And it's also key to point out here that all of the products that we test against are all running their latest engine versions and also their latest signature updates as well. So what I'm going to show you in a moment is an example of an advanced evasion technique in action and how it can be seen within the network security solutions that we have in place. But just to talk you over to give you an idea of what the environment looks like, we have on the sort of the left-hand side of the screen there, we have the untrusted network, and that is where our target system, our attack system is located. Now, the attack system is an in-house tool developed by Stonesoft R&D in order to further improve our own technologies. We've nicknamed the attack tool Predator, and the Predator tool is able to do the encoding and transmitting of packets in all of those possible combinations of ways. What we then do is attempt to deliver the exploit through our chosen security solution, again from the Gartner Magic Quadrant, and we're attempting to target our vulnerable host that is protected by that security solution. So what you're going to see in the next clip is the attack taking place and the results of the attack when we use advanced evasion techniques and when we don't use advanced evasion techniques. So I'm just going to bring up the attack demonstration now. Okay. So what we're going to see here is advanced evasion techniques in action using the manual interface into the Predator system. First off, we're going to do an attack without any network security in place at all, just to show you what the intended result is. So over on the left-hand side at the top there, we're going to choose the vulnerability that we're going to deliver. It's the Microsoft Server Service vulnerability, which is also known as the configure worm. We're not going to choose an IPS system to test through. We're just going to execute the attack against our Windows XP2, our XP Service Pack 2 machine. And down at the bottom there, we can see that the exploit has succeeded, and we're able to open up a command shell which shows that we have full access over our target system. So that's the intended result. The next phase of the test is to repeat the attack, but this time through a Gartner Magic Quadrant security solution, and see what happens. But we're not going to use advanced evasion techniques at this point. So we'll select our Gartner Magic Quadrant device, and we'll launch the attack again. We'll clear the log first and execute the attack. Now, config being quite old now, we would expect our Gartner Magic Quadrant device to be able to successfully detect and block this attack. And if we look at the results there, that's exactly what happened. We were unable to get our shell connection, and therefore the exploit failed. And also now, if we take a look at the logs for this device, if we reload the log entry on there, what we will see is indeed a log entry that shows a successful block. The time frame on there was 14, 29 and 50 seconds, high priority, and it was a successful detection and block, which is exactly the result we were hoping for. Now, this time round, we're going to do the same attack again through the same security solution, but this time we're going to change the way we encode and therefore transmit the packet using advanced evasion techniques. So we select a number of evasions that we can apply from the right over here. So this is at the net BIOS level, and we're going to execute this attack again. So remember, last time without advanced evasion techniques the attack was successfully blocked. This time we just changed the packet slightly, and we can see that we were able to get shell and the exploit succeeded. And if we go back to our security engine, we have a look at the logs. Let's resend the logs. We've still got the original log entry in there. We'll reload the logs again just to make sure that the logs aren't delayed in any way. And as you can see, there's no new log entry generated from that attack. So there are two worrying factors there. First one is that using advanced evasion techniques, we're now able to successfully bypass that network security solution. But also slightly more worrying is the fact that we've been able to do that and not leave a trace in the threat logs as well. So you can see there that that security system was successfully bypassed using advanced evasion techniques. So how do we protect against advanced evasion techniques, or how can you protect against advanced evasion techniques? Well, the Stonesoft IPS system uses what we call multi-layer traffic normalization, and we found that this is the only reliable way to successfully detect and block advanced evasion techniques. And essentially what happens here is that the Stonegate IPS is able to decode and normalize the traffic, or reassemble the traffic as it passes through the solution, and therefore we can see the malicious content without the evasions applied to them and then stop it using our standard detection capabilities. We're also able to offer dynamic protection, and what I mean by that is that Stonegate IPS is actually a software solution, which means we can very quickly make changes to the solution and distribute those changes out via the centralized management platform that we operate, which means when new anti-evasion updates are available, the management center receives those updates automatically and can then disperse them out to all security devices under its control. Now, in terms of our competitors and what most other vendors do, the way that they inspect traffic is based on this method that you can see in front of you now, the vertical inspection of data. And what that means is that down at the sort of IP level, that decoding and inspection capabilities are sometimes sacrificed in order to improve performance. So they may get the performance boost, but you're actually sacrificing the security in relation to that. So when it moves up a layer, we then get partial or even no evasion removal, which means then that the majority of the traffic is left without evasion removal. So the inspection can't detect the malicious payload within there because the evasions still apply. And that applies at the third layer as well there that we can see. So we're unable to detect and block exploits because it's either we're getting unreliable results or it's actually impossible to block the exploit because none of the evasions haven't been removed in the lower level, so therefore they can't even be removed at the higher level. So the difference where Stonesoft comes in is that we apply the horizontal inspection process, which is data stream based rather than a per packet or segment based. And this is the full stack normalization process that I've been talking about, which means we can normalize traffic across all protocol layers on a continuous process, which means then we can remove the evasions and make that traffic evasion free, so we can strip away the camouflage so that we can actually see the payload as the intended device will see it, which means we can then detect the exploits from that evasion-free data stream and have put in whatever response mechanism that we need to do, whether that's a straightforward terminate, whether it's a permit, but we'll record the full session as it's going through, and obviously alert and report that to system administrators via emails, text messages, SNMP traps, or whatever mechanism it is that you want to use at that point. So what are the differentiators then from a Stonesoft solution when it comes to advanced evasion techniques? Well, the first one is the full stack visibility. Stonesoft decodes and normalizes the traffic on all protocol layers, which means then we can do this normalization-based evasion removal. Because once that process has taken place, we can then begin the actual data stream inspection. And because we use the horizontal data stream approach, the vulnerability-based fingerprints then can detect the exploits held within the data and therefore initiate the correct response that we want to do. And we've also got the in-house evasion research tools. Remember, we've been doing research now in advanced evasion techniques since 2007, so that puts us leaps and bounds ahead of our competition. And we have the Predator tool that allows us to do 24/7 evasion testing against not only our own solution, but also against our competitors' solutions as well. And within the Stonegate IPS, we have the built-in evasion recognition and logging capabilities. So not only do we identify when malicious code is being attempted through your network, but also if evasion techniques have been applied to try and hide that attack in progress. And again, finally, with the dynamic updates and upgrades, we're able to automatically update all of our next generation IPS and firewall engines simultaneously as soon as those updates become available. So what can we do next, or what can you do next to help make sure that your networks are not vulnerable to advanced evasion techniques? Well, we have a system called the Advanced Evasion Readiness Test, where depending on the situation you find yourself in, you can use this Advanced Evasion Readiness Test to test the effectiveness either of your existing security against evasions, or if you want to deploy new security, you can use it to test that infrastructure as well. So if you need to determine where you are today, i.e. perform an audit of the existing security device, then you can see whether evasions pose a threat to you or not by using the AERT system. If you're looking at a new network security solution, then how do you know which product offers you the best protection against evasions? Well, why not use the Advanced Evasion Readiness Test to test those functionalities within all of the various vendors you wish to test? Or even if you're just simply redesigning your network security and want to do an upgrade on there, you can choose to test certain portions of that network by using the Advanced Evasion Readiness Test, which you can see with the diagram at the bottom there. What actually happens is we place the Predator attack tool on one side of an existing security device, place a vulnerable target system on the other side, and we run the evasion tests. And the idea here is to test the effectiveness of that security device, not to see which vulnerabilities or which applications have vulnerabilities on your internal servers, but to test the actual security capabilities of the network security device that's in place. And once that test has been complete, then a report can be generated to tell you which evasions were tested, which ones were successful, which ones were unsuccessful, and then also any recommendations that can be made to help improve or bolster your network security. So before I leave and complete this presentation, I'll leave you with some comments from some industry organizations there. And obviously, as an organization, Stonesoft wouldn't expect you just to take our word for advanced evasion techniques. We're also working with the likes of ICSA labs and NSS labs who have both independently tested and verified our findings within the advanced evasion technique world, but also we're interacting with a number of research organizations as well, from government through to education, who are pushing the field onwards and taking advanced evasion technique research to a sort of the next level. So all that remains for me to say at this point is thanks very much for your time again, and I'll pass back to Steve.
Thanks, Alan. That was a really good demonstration there. So what I'm going to talk about now is Hyperglance and give you a demonstration of what this 3D visualization tool is all about. So before I dive straight into the tool, I just want to give you a bit of a background to sort of how it came about and why it came about really as well. So I've just shared the product on my screen, so hopefully you can all see it there now. Hyperglance is a 3D network visualization tool, and it was born out of the idea of one of our CTOs. So he would go in, he would spend his days working in the data centers, he would sort of spend hours drawing out these sort of flat 2D diagrams of the network, and he'd just be thinking, there has to be a better way to do this. You know, when he went home at the weekends, he would be quite happily sitting there flying through these 3D worlds on his PC, and he just thought, well, is there not some way that we could combine the 3D worlds from computer games and the 2D sort of visualization problems that we have with Visio? And so what he came up with was the concept of Hyperglance, where a detailed diagram of the entire IT infrastructure is generated automatically, and it's then displayed in a 3D format, so you're not trying to go through lots and lots of different diagrams. You can see it all on a single pane of glass. And this is where we've got to today. So what I'm showing you currently is a 1600 node network. You can see that centrally we've got things like routers, got cloud-based devices, so areas such as Amazon Cloud in this instance, and we've got virtual devices as well. So we've got things like physical ESX hosts, and from these physical ESX hosts we're then looking into the virtual world, and we can see areas such as virtual machines attached to it, the storage devices attached to it as well, and just get a great idea of what's actually going on both at the physical and virtual layers of the network. And this is something that's really becoming very important today, because what you're finding is a lot more businesses are considering migration to the cloud, and yet they're thinking, well, how am I going to keep track of my data? You know, how do I know it's safe? How do I know where it's residing? And how do I know how those machines are performing? So this is one of the sweet spots that Hyperglance can really help with, as well as the traditional IT infrastructure management, monitoring and troubleshooting. So you've got this image of the network, but you're thinking, well, you know, that's just an image of the network. What is that to me other than knowing where my devices are? And this is where the filters come in, and this is really the power of Hyperglance. It can take in multiple feeds from many different sources, and these are called collectors. So a collector can be defined as an existing management tool within your network, and we've already got quite a large number of collectors defined to extract data from such products as SolarWinds, VMware, Excel, HP OpenView and so on. And this can take that data from your existing management tools and use it to build this image of the network, and then overlay performance metrics on top of that. So you can use this to correlate data events. So if you see that a server is running too hot, then you might be able to identify what the root cause of that is. It could be a denial of service attack, or it could be a bandwidth issue, or it could be a CPU issue. So it really helps you narrow down what the problem is and quickly identify it without having to go through your network team, your server team, your security team. You know, this is where you can correlate multiple sources. so you can Hi guys, I think we had a bit of a technical difficulty there and I may have dropped out. So I'm going to sort of take you back to near the start of my Hyperglance demonstration just to make sure you've not missed any critical points in this. And what I'm showing you here is a description of RAM capacity within the network. And so we're seeing where our devices are running hot and also where they're running cold. So in this instance, we've got a sort of 70% utilization threshold to say high RAM usage. And this can be easily changed to whatever you like, so say 85%. And as you can see, the diagram now gets updated accordingly, and the devices which meet that criteria are highlighted, the ones that aren't are not. And this is just a very quick and powerful way of being able to say, where are my resources being overutilized and where are they being underutilized? And you can use this to then reallocate resources without having to go through every single device and say, right, is this device running too hot? Is this device running too cold? Do I need to buy more RAM? You know, this can really help you save costs in capacity analysis. So I'm going to take that filter off now, and I'm going to show you another one which is similar. This one's looking at bandwidth capacity within the network. And this focuses on similar principles to the previous one with RAM. So we've got set threshold values which say whether or not the RAM capacity is running too hot or too low. And can you highlight this? So in this instance, what we're seeing is this one link here is running over capacity. And this could be causing a serious bottleneck within the network because this is to do with the core infrastructure. And yet you can see the links to the left of that, actually they're coloured blue and they're running at low capacity. So that's suggesting there could be a routing issue within the network. And from then on, you could select that router and Hyperglance will hook into your existing management tools. So you could go to SolarWinds or you could SSH directly onto the router to diagnose the root cause of that problem. So one thing which is also really great for Hyperglance is looking at sort of security aspects of the network. If you have a patch management system, Hyperglance can draw out data from that and it can overlay onto the network to say, show me what devices within my network are vulnerable. So vulnerable would be classed as running an unpatched version of software that has known vulnerabilities. And you can see here we've got a number of nodes which are flashing, and these are both network devices. So that could be running a version of iOS with known problems, or they could actually be server devices as well. And so based on this, we can then identify what devices there are within the network that we have to patch. And you can see on the left-hand side here, there's a list of devices. So we can use that and we can export this data as a CSV file. and use that to then generate a patch schedule within the network to fix those devices. On top of that, you could load, say, a spreadsheet from your asset management database, and you'd say, identify all my devices which are critical within the network. So we've got a number of glowing hotspots over here. Each one of these hotspots is, you can make it whatever color you want. In this case, it's blue. It's completely up to you. You can make them glow, flash, or you can exclude other parts of the network so you can focus in on only the information which is interesting to you. And then on top of that, you could take a feed in from your intrusion protection system. So say you've got something like Stonesoft suite of products. We can take in data from that to identify what devices within the network are actually under attack at this present moment. And you can see there's a number of devices which are flashing within the network which need to be investigated to say, right, these are some of our devices which are under attack. How are we going to fix that? But you can see here there's actually quite a large number of devices. There's about 10 devices in the network here which are under attack. So how do you focus your resources? And that's when you can stack the filters. So you can take in feeds from various different sources and display it as a single image. And this is what I've done in this particular instance. So I've got a filter here which is saying show me my attacked systems, my vulnerable systems, and my critical systems, but then highlight what machines, if any, meet all that criteria. And you can see here I've got one particular device which is flashing red, and this is my credit card processing facility. So this is really a business critical server in this demo, and it's showing that if this one goes down, then the business will start losing money. So I'm just going to show you a couple more demonstrations just to see the different capabilities of Hyperglance. If you were using it in a sort of network troubleshooting scenario, then you might want to look at response times within the network. And so this particular filter is saying I've got predefined response time, but I want to highlight any servers which are over that. And you can see over here we've got a cluster of servers which are all running at very high response times. And so you might think, they're all virtual machines, they're all hanging off that one ESX box. There's probably a problem with that ESX box. And we could go into the VMware vSphere client to actually look at that if we want. But maybe there's another issue within the network, and that might be checking the network health. And what I've done here is I've overlaid the network health, and what that's showing me is this link is got errors. In this instance, that could be something like a duplex mismatch. So something which is easily correctable. You would then hop onto the switch down here, and you could then SSH to that switch, and you could set the interface accordingly. So I've shown you a number of ways you can filter data based on performance metrics and use it to troubleshoot, but say you're only interested in a small part of the network. Say you're a regional IT manager and you don't want to see the entire network infrastructure. Well, we can exclude the parts which aren't interesting to you. So if you're in charge of the USA region, then you could load that filter up, and what it will do is it'll exclude the networks, only showing you the interesting parts which are relevant to you. And you can then overlay filters on top of this just to focus on this area. So we're looking at the USA region, but then maybe I want to look at the RAM capacity for the USA region. And that way you can really drill down into what aspect of the network it is that you're interested in, and not worry about having extraneous data sort of getting in the way of your views, as you would often find when you're looking through the traditional network diagrams. A final thing I want to demonstrate to you here is looking at a cloud-based infrastructure as well. So in this particular demonstration, we've got an Amazon EC2 cloud collector, and this is taking in data from Amazon itself to look at a cloud-based infrastructure. And if we're only interested in looking at that part of the network, I can then load up the filter which will show me the cloud structure only, and it will hide all other aspects of the network. And from here we can then start looking to see where your data is residing. So in this instance we've got flags which are based on regions. So this can be using an IP address, for example, to see what region those servers are based in. And we can display this, so you can then use it in terms of data compliance. So with things like the UK Data Protection Act, you need to ensure that your data is within the UK boundaries to be able to be fallen under that. And likewise, you might want to be wary of it being in the USA, because then it falls under the Patriot Act and allows the federal government to access that data if they so wish. So this is a very strong way of being able to dive on and actually look at the cloud as one of the aspects. And so that's pretty much a brief demonstration of Hyperglance. I hope that's given you a good level of insight into what is actually going on within the network. What I want to do now is just open up the floor to any questions that you may have, and we're going to run through a sort of 10-15 minute Q&A session.
Okay, so we have had some questions come in, and I think the first one, Steve, is for you today. What are the hardware, software requirements?
Okay, so with Hyperglance, it has fairly modest hardware requirements. So the underlying operating system is based on CentOS 5.5, 5.6. You need a server which has got about 8 gig of RAM and about a dual RAID 300 gig hard drive. As far as CPUs go, standard server CPUs which you get today will cover it, dual quad-core Intel AMD. The main constraint is the actual I/O impact on the hardware, so you need a decent level of I/O capacity. And one thing which should be noted is Hyperglance can run either as a physical server or a virtual appliance as well, just as long as that sort of RAM and I/O capacity is available.
Great. I'm now taking a question. I think this one should be for you, Alan. Do AETs really exist, and have they been seen in the wild?
Right, yeah, well, the short answer to that is yes. There are a number of places in which we've seen them. First off, Stonesoft as an organisation, we're a global organisation, and as a result of that, we have various honeypots set up around the world, where obviously we like to entice people in to see what methods they're using to attack systems. And a lot of the AETs that we've built into and shared with the likes of CERT have actually been found within those honeypots. And also we've got people who've seen them in the wild, such as e-crime research specialists. We've got a research partnership going on with Professor Andrew Blythe, who heads up the Information Security Research Group at the University of Glamorgan, and he also does a lot of work for the government in terms of network forensics and security, and again, he's also reporting that he's seen these in the wild. So yes, the answer is yes, they are in there in the wild.
That's great, thanks Alan. Another one for you, Steve. How does Hyperglance create the diagram? Okay,
so when Hyperglance is drawing out this network topology diagram, it's not a manual process. It uses various collectors, which I mentioned in my presentation. So it will use things like hooks into your existing network management system. If you don't have one in place, we can install OpenNMS, which can go out and discover devices within the network and build up this topology diagram automatically. And it also incorporates a dynamic physics engine. And what this does is it lays out the diagram. So once it's got the data telling it where the nodes are all interconnected, it then uses concepts of things like attraction, repulsion, and weight to size the diagram and display it in a manner which is a lot more visually appealing and also makes it a lot clearer to the user.
Great, thanks, Steve. Alan, another one for you. What is the real threat? Who are AETs used against, and who is most at risk?
Right, okay. Well, in general, I'd have to say, obviously, everyone's at risk. Anyone that has a network connected to a public network such as the internet. But obviously, what you've got to start to do is start to balance out the risks and determine the types of assets that you have within your organisations. So, for example, central government departments, they're going to be quite high at risk, from other nation-state attack sort of things. Large finance organisations, pharmaceutical companies, anybody using industrial control systems such as SCADA networks. But as I say, in general, anybody with intellectual property that they want to protect and keep hold of. The actual threat is that with the majority of existing network security solutions on the market, administrators tend to be left with an almost false sense of security. They believe that they've deployed their IPS, their IDS, as I mentioned earlier on, and it's doing its job and protecting them from malicious code. But obviously, what we've just seen from that, my presentation is that that's actually no longer the case, and that belief, you can no longer take that for granted.
That's great. Thanks, Alan. And another one for you. Why are Stonesoft the only ones discussing this at the moment?
That's a pretty good question, actually. It's one that we get asked quite a lot. I suppose that the only answer we can give here is that the other vendors are actually ignoring or playing down the threat of AETs purely because they're not able to protect against them properly. As we've seen throughout our research, the only way to protect against AETs is to do the traffic normalization and reassembly, and that actually requires a very thorough understanding of the network protocols being used. Other vendors have tried to rely purely on signature definitions to try and detect the evasions being used, or the atomic evasions being used, but not the advanced subset of evasions that number in the billions. So this means that, yes, they can protect maybe against the hundreds of evasions, but unfortunately not those billions of evasions that are out there with the possible combinations. So the short answer there is that other vendors are unlikely to talk about and promote this because they're unable to defend against it.
Great, thanks. Steve, one for you. What management tools does Hyperglance support?
So Hyperglance really relies on gathering its data from what existing management tools you might have within your network. If you don't have any in there, then we would go and set up OpenNMS to provide a sort of network management system to pull in data. But Hyperglance does support quite a variety of tools out of the box. I mean, some of the key ones are VMware. This was really one of the first tools that we did support, and we've got access to not only their public APIs but also their private APIs, so we can get a very high level of detail from vSphere about the virtual machines and the virtual estate. Other collectors we have include an Excel CSV collector, so if you had, say, an asset spreadsheet, or you had a spreadsheet which was describing various different aspects for the servers, so it could be defining business functions, levels of criticality, things that you wouldn't normally get in a management tool, we can hook into that data and load it in. There's also collectors for storage, such as EMC and NetApp, and there's a number of others which are currently in the process of being finalized. One of the things with Hyperglance is it's designed to be extremely flexible when it comes to data collection. So if there's a tool which you're using which is not currently supported, we can work with you to actually incorporate that into Hyperglance and take in the data from that tool.
Great, thanks, Steve. Alan, one for you. How did Stonesoft discover AET AETs?
Well, actually, I mean, as we're a vendor of a security solution, we produce network-based IPS, IDS, and next-generation firewall technologies. It was actually as part of a project designed to improve the overall security and capabilities of our own security device. When Stonesoft R&D first began the research into Evasions back in 2007, there wasn't a specific tool that allowed them to test the equipment comprehensively. So essentially, they developed their own testing tool, which we call Predator. And it was through the development of Predator that has ultimately led to the discovery of these billions of previously unknown attack methods, and many of which can be used to bypass many existing security solutions today.
Great, thanks. And then I think final one here for you, Steve. How is Hyperglance licensed?
Okay, so Hyperglance is based on a sort of value-add licensing scheme, which is controlling of the actual maximum size of the diagram you see on screen. So essentially, the license is based on the number of nodes that you have within your network. And a node in this sense is defined as any manageable object. So that can be a router, a switch, a firewall, a virtual server, or a physical virtual host as well. And so, for example, the licenses available come in very many different sizes. For example, you might have a license for 10,000 nodes. And this is something that we would discuss with each customer to size it appropriately for their needs.
Okay, great. And I think a final one for you, Alan. I think this is the last one that we'll be able to take today. Why can't other vendors protect, and won't they just catch up in a few months?
Right. Okay. Well, I suppose. Well, first of all, I think the reason most of our competitors or the other vendors can't offer adequate protection against advanced evasion techniques is down really to the way that their solutions inspect the traffic, and that's going back to the vertical inspection as opposed to the horizontal inspection that Stonesoft does, as I mentioned in the presentation earlier. I think other reasons might be down to the actual types of devices being used as well. So, for example, hardware-based security solutions versus software-based. Hardware-based solutions that use ASIC-type technologies, they tend to be restricted to the amount of capacity that they can support, and also to the amount of resources that are available to them. So, whereas software-based solutions like Stonesoft's, they're much more flexible in terms of resources, and also more dynamic when it comes to the update of those devices as well. And I think a major reason, and probably one of the key reasons actually, is that the other vendors and our competitors don't actually have a tool like Predator. It is essentially a one-off when it comes to an automated testing system for testing evasions against other solutions. So I think to answer, won't they catch up in a few months' time? I think my answer to that would actually have to be it's unlikely. Again, because if you bear in mind that Stonesoft now are almost 5 years ahead of all of the other vendors when it comes to the evasion research. So our knowledge is there, and we're just going to continue to build on that knowledge as we go along.
Okay, great, Alan. We've just got time for one final one that's just come through from Simon. How long would it take to set up OpenMNS and Hyperglance on a small internal network?
So the actual setup time for Hyperglance and OpenMNS is not particularly great. It would probably take a matter of a day or so to actually get it up and running. And then what we would do is we would work with the organization to ensure we're seeing everything within the network. And we would check things like SNMP, for example, just to make sure that all the data they're expecting to see is actually shown on the screen itself. But if you were deploying Hyperglance as a virtual appliance, it can actually be deployed extremely quickly. We can turn up on site with a pre-configured virtual machine and load it up, and it'll be up and running in a matter of minutes. We'll only need to do something such as OpenMNS, where we would configure the discovery and add in things such as your SNMP community strings, so we could draw out that data from within your network. And I think that covers all the questions we've had for today. So I'd just like to thank you on behalf of myself and Alan for attending. If you do need any more information, or you would actually like to look at a sort of one-to-one demo, then please contact us. Our office number is displayed on screen. It's 0845 226 4167. Or you can email us at contact@intergence.com. And one other point to note is later on in the year, we'll be running a number of executive seminars across the UK. There's quite a bit of information on our website about this, and myself and some of my colleagues will be talking at these. So if you can, certainly get yourself along to those. So once again, thank you very much for your time, and I hope this has been really informative for you.